Hi guys, you welcome back to my channel. Today I will love to drop a particular video on organic reaction, and this organic reaction is being specified on Jupeb. For those students out there who are preparing to take Jupeb examination, this video is for you, and to some other students at university or college of education, this video is for you as well. So now let's go back to this. What do we have on the board? We have organic reaction based on Jupeb syllabus. What is organic reaction? Pay max attention to this class. Organic reaction are those chemical reaction which are undergone by organic compound. Again, organic reaction are chemical reaction which are undergone by organic compound. Now, if we are to take a look at what is organic reaction based on Jupeb syllabus, we'll be looking at some types. The first one we're going to take a look at is addition reaction. The second one is substitution. We as well have elimination. We also have hydrolysis. While the last one, which I'll be taking here, it will be our condensation. So guys, we are going to pick this according to the Jupeb syllabus. What do you understand by addition reaction? It is very simple. So those students out there in your secondary school level, they will tell you that addition reaction is a process at which you are going to substitute the double bond in the presence of a particular catalyst to give you a single bond. No, it is correct, but to those students out there who are writing the Jupeb examination, you can easily take this addition reaction as a types of reaction, or it involves two or more reactants which they combine together to form a product without the loss of any of the reactants formed. And mainly, addition reaction are the reaction which are being classified to mean unsaturated hydrocarbon. For every addition reaction, it occurs when two or more reactants combine to form a product without the loss of any atoms present in the reactants. And don't forget one thing which I stated earlier, that in your secondary school they will tell you that for every addition reaction they are unsaturated hydrocarbon. Yes. And why is it that they are classified as unsaturated hydrocarbon? You know, for every unsaturated hydrocarbon, it involves two or triple bond. That is, it's the kind of hydrocarbon which we have a double bond and a triple bond with further attachment of other atoms. That is, for every unsaturated hydrocarbon which this addition reaction exhibits, we can have it as either double or what? A triple. This one is a what? A double bond. While this is a what? A triple bond. So you can easily say that addition reaction exhibits completely unsaturated. That is, now if you take a look at this example, the reaction between ethene and hydrochloric acid, what will be our product? So let's take a look at that. I have ethene, which is C2H4 plus, you can say hydrogen chloride. What will be our product? Don't forget I said it occurs when two or more reactants combine. Two or more reactants combine to form a product without the loss of any atoms at the reactant site. So let's take a look at this now. We are going to show the structural formula of ethene as well as our hydrogen chloride. So this is it now. How many carbon you have? We have 2, and this hydrogen is what? 4. So let's take a look. We have this plus this. So now, if they can occur when two or more reactants combine to form a product without the loss of any atoms at the reactant site or present in the reactant site. So look at this now. We are having 8 here. If at all this hydrogen here is coming to this place, mind you, we have a pi bond here as well as a what? A sigma bond. This chlorine coming to this place now have the priority to break this double bond to give us a what? A single covalent bond. And giving us that covalent bond does not tell us that hydrogen cannot come in. It's just like I said, if you have the hydrogen, when you look at our periodic table, having hydrogen and chlorine at the top will give you a clue that they stand alone. But if they come into a particular compound, they will take effect irrespective of what hydrogen is combining with. Is that clear now? So with what you have on the board here now, if this one here, if this chlorine can have that priority to break this double bond, mind you, what you have here, the cleavage of this is this. So hydrogen here will be coming to this place. With that, I can say that I have this, and mind you, this bond is going to what? Turn to a single bond. We are left with what? A sigma bond, not a pi bond. So is that clear now? So with that now, I can say that I have one hydrogen here. The second hydrogen is here. Plus, we're having our Cl here. If we are to take this now, CH3, which is this, CH2Cl, and go back to the alkyl group, if you're having this, it is called eth, and mind you, we make use of what? A hydrogen chloride. So nothing like eth-chloro, because in organic chemistry, our chlorine is taken to be what? Chloro. But then, if you're having an alkyl group reacting mostly with the halogens, we'll be having eth-bromide, eth-chloride, like that. Is that clear now? So with this now, I can say that I have eth-chloride. Are you with me now? So this is all about what? Addition reaction. So we'll take a look at the next one, which is a what? A substitution reaction. But before we go to substitution reaction, I want you guys to pay max attention to this explanation. I said earlier that this addition reaction, they exhibit completely the unsaturated. And mind you, for every unsaturated hydrocarbon, they contain a double bond, a triple bond, with further attachment of other atoms. If you take a look at the other way around, which is what? Saturated, there won't be space for any atom to come in. Is that clear now? Addition reaction. So this, let me summarize it before I take it on the board. This involve the reaction between a group of atoms or let's just say, okay, it involves a group of atoms which are substituted by another atoms or group of atoms to form a new substance. It is like you're saying you have A plus B going to the product side, it is being substituted to another thing. So now let's take it again. It involves a group of atoms which are substituted by another atoms or group of atoms to yield or to form a new substance. It occurs when an atom or a group, an atom or a group of atoms are substituted by another atom to form a new substance. So note, they are generally saturated hydrocarbon. Is that clear now? They are generally what? Saturated hydrocarbon. It occurs when an atom or a group of atoms are substituted by another atoms to form a new substance. So listen to the example now. The conversion of methane to form chloromethane a substitution reaction because the hydrogen atom is replaced by chlorine, is replaced by what? Chlorine. In a nutshell, they are telling us directly that the reaction between methane and chlorine gas will yield chloromethane. So now let's take a look at that. What is the molecular formula of methane? Okay, so you can just put it like this, that methane plus chlorine gas will give us what? Chloromethane. The next one we're going to have here, we don't know it until we show it, or we show the mechanism of it. So now let's show a brief mechanism of that. Methane is CH4, while this is what? Cl2. Is that clear now? So let's take a look at this. We have one carbon here, 4 hydrogen is attached to it. You know, I stated earlier under the addition reaction that for every addition reaction we have double bond, triple bond, there is further attachment of other atoms to come in, irrespective of the kind of atom that is coming to what? The double or the triple bond. But this, it is saturated hydrocarbon, and for every saturated hydrocarbon they involve in a single covalent bond without further attachment of any other atoms. That is, no atoms can come into this what? Methane. The only thing we can do here is that we can replace. That is why we have what we call a replacement reaction. Is that clear now? So now, one of these chlorine here will be what? Reacting with this. So that is why for this kind of reaction, for those of you that are familiar with organic compound, we have the initiation, we have the propagation, as well as we have what? Termination. So we have, under this particular reaction now, we have 3 steps. The step 1 is initiation, the step 2 is propagation, while the step 3 is called what? Termination. So with this now, if this should react to this, here will be vacant for this chlorine to what? Come in. With that, I can say that I have Cl plus 8Cl. You know, I think guys, we don't know what is here. Hope you guys are taking note of what I'm saying here. So with that now, this is what we call chloromethane, while this is hydrogen chloride. This is the explanation on substitution reaction under organic reaction based on our Jupeb syllabus. Is that clear now? Reaction. So before we have this now, for every elimination reaction, generally they involve the removal of adjacent atoms or a group of atoms. So now you can say you have some reaction involve elimination or removal of adjacent atoms or a group of atoms. So note one thing, when a multiple bond is formed and a small molecules as a product, a small molecule of a product will produce alternate double bond. This particular word now, I will have to explain it with example now. So to back it up with example, conversion of ethylene, conversion of ethyl chloride, to ethylene. Some of you will be like, what is ethylene? Ethylene is the same thing as ethane. Is that clear? So now, we all know that when we talk about elimination, we have to eliminate completely. Is that clear now? We have to what? Eliminate completely. So now guys, some reaction involve elimination or removal of adjacent atoms or a group of what? Atoms. Note, when multiple bond is formed and small molecules as a product, we produce alternate double bond. This word we produce after series of what? Research I did myself. If we have a multiple and a small, you can say small reaction or small molecules of bond or small bond of what? Molecules, but as a product we produce alternate double bond. So to back that off, we have this conversion of ethyl chloride to ethylene. Just like we're saying, the product side of under the addition reaction will bring the what? The starting, or we call it will be at the reactant side, which will be starting this reaction. So what is our ethyl chloride? But before then, they said ethyl chloride will give us what? Ethylene, or we call it what? Ethane. Is that clear now? So guys, our ethyl chloride is CH3 CH2 Cl, and why this we have what? CH3 H2 double bond, CH2 plus what? You can see we produce alternate what? Double bond. So guys, let's go back to this. Let's have the what? The structural formula of this one. So let's go back to this. How we have a multiple, okay, you can see a single bond here, a single bond. If you observe vividly, at the reactant side, it is saturated. While at the product side, it is what? Unsaturated. Now, we have to eliminate removal of, let's go back to this, removal of adjacent atoms or a group of what? Atoms. So we are going to what? Remove this. To back that definition of that, removal of adjacent atoms or group of atoms. With that, for you to have eliminated, don't mind, here is a what? A sigma bond. If you have to eliminate these two, it will be what? It's going to yield a double bond. The main reason why I make use of multiple bond is because if it does not yield a double bond, we can have a what? A triple bond. So it's that this will give us what? One hydrogen here, C, another hydrogen here. So this one here, these two that I are removing here, which is the adjacent atom, will lead to what we call a double bond, which are going to have a pi here bond and a what? A sigma bond. With that, you can say that I have one hydrogen here plus HCl to back this up. So here is a what? What elimination reaction encompass? If you have any question, you can easily drop it in the comment box relating to Jupeb syllabus. And if you want us to tackle any video on that, drop the topic in the comment box. And guys, don't forget to subscribe to our channel. As well, I want to appreciate the effort of all our subscribers out there for taking us to 800 plus. We are getting there. Is that clear now? So let's take the next one, which is hydrolysis. Hydrolysis reaction. So before I explain that, let's take a look at these short note on the it. Let us say water is commonly used. It's common, okay, let's put it like this. It's common in a chemical reaction where water is mostly used to break down a chemical bond that exists between that exists in a particular substance. Is that clear now? So if you have AB plus water, what are you going to have? This water, if you split it, we're having what? This. One will be picking this. Why do now what? Reacting with this. So we have AH plus BOH. Is that clear now? So now, let's take a look at water itself. That if you have water, what are you going to have? We have hydrogen ion plus hydroxy ion, because water in a chemical reaction, they are mostly used to break down a chemical bond that exists in a particular what? A substance. So let's take a look at this. We have ethanoate will give us what? A carboxylic plus hydroxy. So now how do we have this carboxylic and what? Hydroxy. It has the alkanoic. You can see we have alkanoic and what? Alkanol. For those of you that did not know, so this is it. So now, if I have CH3, COO and what here? CH3. This will give us what? How can we easily have carboxylic as well as what? Alkanol. So, if I want to add water to this, water we are using here is more of like coming to this particular reaction to break it down into some chemical bond. So now with that, now there will be a cleavage here, and when you separate these two, we have OH here. This H here will be coming to this what? This COOH. Why this OH here is going to react with this, and with that, let's write this. When our reading is coming in, we are going to have CH3 COOH, is that clear now, plus CH3 with what? OH. Look at this, negative. Look at this, positive. Is that clear now? So everything is acting more or reacting with this to break the bond that exists in a particular what? Substance. So now this is called ethanoic. Why this is called methanol? The only thing you need to know about this is that you are getting to know if or what is the effect of water if it should react with any compound. Hydrolysis, and we all know that we are the addition of water to a particular compound. What are we going to have as the end product? Now, this is a clear picture of when water is reacting with methylethanoate. What are we going to have? We are going to have two products, ethanoic and what? Methanol. Easily involved in this. For every chemical reaction, when two or more compounds combine to form a single molecule, and that single molecule usually the loss of the single molecule is what? Water. But then let's take the definition to be in this form. It occurs in a chemical reaction when two or more compound combine together to form a single molecule. Can we make use of compound, but let's make use of molecule here. Let's some more molecule combine together to form a single molecule. Usually the molecule involves the loss of any atoms, and we can make use of that atom to be what? Water. So the molecule we are talking about more here is what? Water. So that is why there is one thing you need to know about this. Note, if water is lost, then the reaction is known as dehydration synthesis. You know what I mean by that? Like the loss of water. So how do we know, how did water loss leave the reaction, and how can we easily what? Compare it if it is dehydration. Note one thing, addition of water in chemistry, we call it hydrolysis, right? While removal of water is called dehydration. So we can easily say for every addition of water we call it hydration or hydrolysis, while the removal of water is called dehydration. So let's take a look at some example under it. For example, now if I have this, we have 1, 2, This is what class? Carboxylic plus this is CH3, CH2, same thing to be what? CH3, CH2, CH2. Why here we have a what? A carbon here. So when you count the number of carbon atoms, 1, 2, 3, 4. This is butanoic. This is ethanol. Now, how is there loss of water here? Because the moment you are removing water from this place, there's what? A trouble. And that particular trouble here, or the kind of thing we are going to have here is that, what is the next compound we are going to have? Now, for us to remove the water now, there will be here is what? Hydroxy. And here is what? Hydroxy as well. So if which one is stronger, cannot alcohol, you can see it is very what? Strong. So we are going to what? Separate this. Oh yeah, positive here. So I'm going to what? Be a cleavage here. So by removing this H here, reacting with this, we are having what class? Water. Is that clear now? So with that, I can say that I have 1. Don't forget, here will be O, and here is that clear now? There's a double bond here, please. So this functional group is called esters. That is the alkanoids plus what? You know we have removed what? Water from the compound here. So we have what here class? H2. So now let's count. 1, 2, 3, 4. This, if you have this, it is called Eth. Why this butanoic here? Because of these esters here, this oic here will be accepting when you go to the product side with what? Oits. So with that, we can say this will be coming first. So we said ethylbutanoids. So we have successfully combined 2 or more molecules. You can say 2 or more molecules together to form a what? A single molecule. You can see we have a what? A single molecule here. But initially we have what? 2 or more molecule to form a what? A single molecule, which involve the loss of water. So guys, don't forget to subscribe to Chemistry Call channel. Share, like, in the comments box. Drop any particular topics under organic chemistry, either inorganic or physical chemistry that are having difficulties with. Drop it in the comments box, and we promise to tackle each of your questions. Even if it's the thanks, do well to drop it in the comment box. Thanks, and we appreciate your efforts for doing that.